Hello and welcome back. Okay, in the last VGA video we successfully discussed some of the aspects of the timing that were quite important to carry the build forward. But in doing so, we did expose a vulnerability of the system. Because of the modular way I'm putting this all together with a kind of moving line between the PCB and breadboard connections, we've got a lot of these random wires that kind of hook different sections together. And that ended up being a little bit of a distraction. So in today's video, what I want to do is tidy up some of those cross connections and seeing if we can make the build just slightly more robust so it doesn't get in the way of the future videos in this series. So let's take a look at that problem. Right, so I've got the build powered up and the monitor ROM is outputting our basic logo here, which shows us the VGA is working. Now this big mess of wires here is the thing we're really worried about. Now the connections into the breadboards, we obviously need all of those, but I do think we can do something about all of these connections down here. We've got all of these connections from the bus breakout down into this VGA module. And when we started to expand this beyond the tile data we added, I ended up having to create some kind of doubling breakout PCBs to give me enough connections to the mem data and the address bus. And all of that is kind of problematic, and that's added to the problem we've got. Now the bus down here has got all of these connections on the side here. Now we hadn't defined this bus and this breakout board at the time when I defined this backplane, but if I had, what I could have done is stuck one of these bus connections on the side, and then with just one of these little bridge connectors we could have made all of those connections in one go. And so what I could actually do is create a breakout with all of the connections for the tile data and all the other PCBs we've already done, and we'd be a bit smarter about putting output connections for all the other signals so we don't end up having to double them up in the way we did here. And that would be a lot neater. Now obviously the long-term plan is for us to have a backplane for the whole VGA, which will go the full height of the processor build, connect everything up and have all the modules for the sprites, the palette and the output in. And we want to finish the build with that all completed. But we're quite a few steps away from being able to do that, and whilst I wanted to avoid making extra temporary backplanes, I think on this occasion, if we do that, it will allow us to test some of our wiring, simplify this right down, and give us a more stable platform to work on for the remainder of the VGA build. Now, of course, we've been effectively designing a backplane PCB as we go while we hook up all the module components, so we've got most of that already done. So let's jump into Easy EDA and take a look. Okay, so I want to do a bunch of hookups for this with a simple backplane. Don't need any of that. I think I will get rid of the mounting holes on that side at least. Okay, so we've got two things that will access memory that are still to be turned into PCBs. One's the palette, which we've got on breadboard, and one will be the sprite hardware. So if I put in a pair of those, that's going to make our life a lot easier. That would be quite a lot of soldering for a temporary backplane, but I think it will save a lot of effort. Right, so this routing is not particularly pretty, but it claims to be complete. Let's give that a go. This is going to be quite the space saver. I'm trying to work out how to hold these nice and vertical while I solder them. Okay, so this interface board has a few lines on it that are not present or currently used. That's because at the time I made the backplane, I was deciding if I wanted to add some additional registers to the system. So the technique I'm using here is very simple. You just tack a single pin in place and then double check from the other side if it's okay. Very, very difficult to fix it if you've soldered all the pins, but just one pin, you can either bend it into correct position or you can remelt the solder and move it very easily. Here's an example right there of one that went horribly wrong. Right, it's going to be very difficult to make these work with the standard techniques. So I think what I'm actually going to do is see if I can just bridge some of the connections like that. I'll do this one first. I think that might be okay. So these little lone pins here were added to retrofit improved ground where it looked like it was needed. So I think they now stand as a reminder to get it right the first time. I think they're total overkill as well, but it was inevitable I'd swing the other way temporarily. But it's better to overshoot when trying to get good ground connection. Right, so tile map sync gen interface done. It's just tile data remaining. This is the sound output PCB, so everything always comes in 5s, and if I don't make mistakes I usually only use the 1. I must admit, for the goals of this project, having these circuits split up into modules that are then interconnected is really aesthetically pleasing to me, but soldering these backplanes is a real pain. On that last set of 5 pins before this, I made a mistake and melted the 1 pin that was tacking it in place. I got away with it though. Roughly balances that out. Just want to avoid holding it at a strange angle. These 2-pin headers are really difficult to get. So that's all the PCBs done. That's the main bus connectors done. We've just got these outputs up here. Slightly too thick. Now I don't have the exact size ones of these, so I'm using 2 smaller ones. If I hold them with that while I'm putting them in, it should produce a connector I can plug stuff into easily. Put solder in a hole that didn't need it. Okay, I think this is actually half a pin off, so this is going to make it tilt slightly over. So I'm just going to straighten it there and solder the second pin. And in theory, I think we're done. Okay, well, the only thing to do now is to go and get the other VGA circuits and start plugging them in. So I think that's probably best done side by side with the main board. So I'm going to clear away and we'll get the main system out. Okay, so I've got the main build with the VGA circuit connected back out, and here's our new PCB. Now moving all of this across is going to be a challenge, but initially we need to do these PCBs. Just putting that in, it's immediately apparent I've missed this row of pins on the soldering. That's better. Now I'm going to leave this stuff connected for now. Actually, the inputs to this we don't need anymore. Just don't need the power. Now I'm going to try and move the tile data board over. Got to be extremely careful with this because a bunch of bent pins would be very inconvenient. That's nice. And the sync generator should actually be quite a simple one. It's nice. Now, if that doesn't demonstrate how convenient the bus connections are, I don't know what would. Let's start with the easy stuff. The data, got a connection right there for it. Now we can need a longer cable for that, and for that, which we have here. Let's get this power across. So that's the bottom two address lines. That makes sense for the palette. Now the only longer wire pairs I've got are coloured as power, so going to need to be extra careful with those. Right, so we've got 4 lines here which are the colour output. It needs to be a bit longer. So there are additional ground ties I've put in here. Let's put one there. Try and replace that with a longer wire in a moment. So here's the sync lines. Now in the last VGA video we actually swizzled those around a little bit. So I think the easiest thing for me to do would be to put this wire into the breadboard and then just reorder these in accordingly. Now these orange wires are going to be clock signals. Okay, so this blue wire, that is the tile data mem region line. That's not necessary anymore. These yellow lines, that's the memory load line. Don't need those there, but we will need to bring it across from over here. So the header here is an exact reproduction of this header. Don't like that being an orange wire though. And then the one at the far end is mem region palette. Now that's chained across the board, so these purple wires are the mem region selection. So that can come from a bit of a closer location. Long enough? Not quite. I have to use the orange wire for that. It's one of the longest remaining wires I've got. That's everything disconnected. Got an extra ground line there. Let's stick some power in it and see what happens. Okay, I've checked all the power lines. I've adjusted the lighting for actually running the build, and let's give it a try. Right, okay. I can actually see the logo there. Some colours are slightly off, but that's kind of promising that a lot of this stuff is working. Just trying to think about the right way to diagnose this. To clear the tile maps, everything should be black and zeros. So I'm testing the outputs from the tile data now. They are indeed all 0. So that must mean the palette is outputting the wrong data. This should be blue. So we expect this to all be 0. Yeah. 0, 0, 0. Interesting. Feels like the data is getting corrupted on the way to the palette. So much of this has to work in order to have it come this far. So it's force outputting zeros. It's force outputting ones. So we've definitely got different data in there. Right, so putting in a resistor array here. So I should have 8 values in a row that are all low. I'm kind of paranoid about these cables because I remember having a bad one before. So now I'm going to swap that out with this cable. Now writing to a pallet entry now should give me guaranteed 0. So this should be the first component of the first pallet entry. Okay, the first bit seemed really promising. That makes no sense. Yes, it does. That's the address lines are forced to 0. That's a completely failed test. Those are the data lines. I've just noticed that one didn't feel 100% inserted. I'm going to kick myself if it was that. So in theory, we're writing zeros there. And it's not making any difference. Maybe we were right to suspect a cable here. I'm trying to think of what it could be. I mean, let's go back here. So we're forcing the address bus to 0, or at least bits 2 through 10. So when we did this before, we did get an odd colour. That is consistent with us setting blue to 0. So we should be able to set the colours of the first pallet entry here. 1, 0. Alright, so if I force both of those down, we should get the same result. No. Cyan is consistent with the idea that we've just taken the red to 0. So I'm going to turn those round. So now that would be the second line is set high by the power line there. Doesn't actually matter what address we put in there. So that's binary 0, 0, then 0, 1, and now by turning it round, that's 1, 0. So I'm just hardwiring these address lines into the ground and power rail. So if that's consistent with what we're seeing, this will now mean that blue goes to 0. So it looks a lot more correct. This isn't quite right because whatever's happening to the address lines there isn't entirely consistent. So if I put them both back in the ground line, load that with FF, that would be totally red. So the question is, why are we not getting the right data there? So now the bottom 2 address lines are 0, 0. If we step the CPU, the lowest one should be 1, which is what I'm seeing. These are just line drivers. So getting 1, 0 there. But they're both zeros there. I've messed something up. Okay, so we know it's correct here. Follow that. Oh, hang on. Okay. This is both nice and horrible. Correct. Right, so this VGA address bus header, that's pin 0, that's pin 12. that is an idiotic mistake, but one we can fix. Let's get that running again. So if I set 2 to FF, that should be the blue channel, which should make this pink. Bingo. So what I need to do, which of these is longer? So I just need to plug this in the other end, the opposite way around. And let's just reset it. Awesome, that looks right. Okay, so this was a foolish little mistake on the temporary backplane, but it's just a header the wrong way around than what I'd expect. I've made that mistake before on temporary backplanes, but the board actually it works. And if I hadn't made that mistake, it would have worked first time. Let's put it for its paces a bit though and confirm how it's going. So let's go with the parallax demo. I like that one. Yeah, awesome. That works. I'm really happy. I want to show you something else though. Gets boring showing you exact same stuff all the time, even though I'm quite pleased with this particular piece of code. But the last non-VGA video I shared was the SNES controller. And of course, when I first got that in, the program I showed was my doomed demo, which is my kind of vertical strip renderer demonstration code. Now, that video was interesting in its own right, but the VGA was in a very different state when I did that. We just had the tile map operating as a frame buffer. And I have been working out how to get that demo running with the new tile map tile data combination. And I've also been thinking about what I can do to turn it more into a game. There's a big challenge there is the core rendering now only has 16 colors on the display. But I'll show you what I've come up with so far. Got a 1 character offset there I need to investigate. Now, with the 16 colors, that means my graphics, when I first ran it, was completely corrupted because this was just showing characters and stuff. But I've been trying to work out a way to get the graphics working, so I've got a very crude conversion. I've also been playing around with some graphics to kind of put a status bar in at the bottom. This is using some of the tile map tile data techniques I explored in a couple of previous videos. This is non-active at the moment, but the tiles here are all being arranged to be able to create the 7-segment numbering and do the numbering in the letters as I'd like to see them. I do need to spend some time trying to create better textures for the actual world environment, and I'm probably tempted to modify the way I'm specifying the environment. So I don't know quite how far along the way to a first-person shooter game I'm going to get with this, but I definitely want to take it a few steps in that direction, because whilst I originally planned this system to be majority 2D games, the fact that we got the Doom demo as far as we did means I don't want to leave that unfinished. Okay, I'm really pleased with the end result here. The wires are all an awful lot tidier, and I think they're going to be a lot less stable and less error prone in the future as I try and finish off the VGA build. I will tidy up the wires a little bit between videos, but I don't think you need to watch me play around and swap out longer wires for shorter ones. It was nice to be able to show you some of my progress on the Dooms demo. I'm hoping that a bit of a 3D game in the final demo suite is going to look pretty good, but we'll see how that goes, and maybe I'll share some progress later on. But I hope you found this interesting. As always, thanks a lot to my patrons. I do appreciate the support. It really does help keep me going, and I look forward to seeing you again soon. Goodbye.